Okay, so now I'm recording and I will begin my presentation. All right. Is that showing up okay for you?
Yep.
Yep. Okay. So as I said, some lies that we tell our students. I know in Maryland, we use the Common Core state standards for mathematics. In Pennsylvania, Michael, are you familiar with the Common Core standards?
Yep.
Okay. So these standards there are two different parts to them. One part are the content standards, which define the content we want our students to know. And the other part are the standards for mathematical practice, which are ways of thinking about mathematics and how we want our students to be able to interact with mathematical ideas. And one of the key ones is number 6, which is attending to precision. We want our students to be able to communicate precisely to others, use clear definitions in discussion with others and in their own reasoning, and state the meaning of the symbols they choose, including using the equal sign consistently and appropriately. And so if we want our students to be able to do all of those things, we absolutely, of course, as teachers, need to do those things as well. We have to model them. And so this presentation was designed for teachers and future teachers to think about how they talk about mathematical ideas. All right, so the first one, I know I'm guilty of every one of these. Sometimes I say more when I mean add. I'll say like 3 and 4 more is 7. And there's nothing wrong with that. It is correct, it works. And so for example, if we have this problem, the faces end up being in covering it. Does that cover it for you guys, or are the faces separate for you?
It's not covered on my
screen.
For you.
Okay, so just for me. So for this problem, more works. Fatima had 5 stickers, she got 3 more. How many does she have now? Totally, that works, 5 plus 3. And we can model it with a visual like this, where we have our 5 and we add 3 more. And so we can see our sum or our total is 8. The problem is when kids begin to think that the word more always means add. And I go into classrooms, I visit a lot of schools, and I sometimes see these walls of keywords, and it says, when you see the word more, you add. And this causes problems though, because sometimes, kids overgeneralize that. And they see this problem. Jose has 8 toy cars, Angelina has 3 toy cars. How many more does Jose have than Angelina? A kid who's internalized that and is thinking, oh, more, I have to add, they're gonna add 8 plus 3 and have the answer be 11, which of course is the incorrect answer. So we have to be really careful. We don't want kids to just memorize rules like that. We want them to stop and think about what's happening in this situation, and drawing a picture, even something like this model that I have done here could be really useful. And here's another problem where it does not work. Devante had some video games for his birthday. He got 3 more, now he has 8. How many did he have before his birthday? Again, that's really actually a subtraction problem. All right, subtraction means takeaway. Again, I sometimes say that, I'll say like 4 takeaway 1 is 3. And it works sometimes. Rita has 8 apples. She gave 3 apples away. How many apples does Rita have left? This is a takeaway problem. The problem though, of course, is that not all subtraction problems are takeaway. Sometimes it's just finding a difference between 2 different groups. So this problem, we're just comparing. Jose has 8 toy cars, Angelina has 3 toy cars. How many more toy cars does Jose than have Angelina? We have the word more there. And there's nothing going away. And sometimes kids begin to think that subtraction always has to have some action, but really it can just be a comparison. Now, those were somewhat simple problems, but I would encourage you, even for problems that are more complex like this, if any of you have ever worked with young children on a problem like 1000 minus 658 and watched a child or an adult try to use the standard algorithm to solve this, it ends up being a mess of 9s and 11s and 0s and 1s. Kids make mistakes every time. No, and again, many adults will make a mistake. However, what if you think about this as a difference problem? And we think about this as we're trying to find the difference between 1000 and 658. The distance between those 2 numbers is the same as long as I take away or add the same amount to both of those numbers. And so if I decrease both of those numbers by 1, and I change this to 999 minus 657, it's suddenly a lot easier to do that computation. I don't have to do any regrouping at all. I could just easily find the difference or the distance between them. Michael, do you have a thought about that one? I saw a reaction.
Yeah, my mom was just, never like thought of it that way.
I
Yeah.
took math 100 years ago. Totally different.
I never thought of it like that either. That's a good way to
Exactly.
think
And it makes it so much easier, doesn't it?
about it.
I mean,
Those of us of a certain age were never taught how to do that. We crossed off all the zeros.
Yep.
Right.
Yep. And I know that the Common Core has a lot of controversy. And, sometimes people think, oh, we're trying to teach these kids newfangled math. But really what we're trying to do is we're trying to have the kids understand what they're doing and not just blindly try to follow this computation, but actually think about the distance or the difference, and that this might be a more efficient way to do it. And so this is something we would encourage kids to do. Be flexible in their thinking about subtraction. All right, here's another one. Sometimes when we're saying the word equals, instead of saying the equal sign equals, we say makes. And this can lead to some misconceptions with kids. They begin to think that there has to be an action, and so that the number to the right of the equal sign is the answer. And so there's a pretty famous study, this one's from 1999 actually. Kids were asked, what's 8 plus 4 equal to something plus 5? And to me, it's pretty shocking, disturbing, that 76% of the 5th and 6th graders, and you can actually see it got worse as the kids got older, they thought that the answer was 12, because they're thinking 8 plus 4 is 12, and they're totally ignoring the plus 5. And so as teachers, we need to be really consistent in talking about equality, and is the same as is something else we could say there. So we want to make sure we're looking at everything on the left side. 8 plus 4 is equivalent to something plus 5, and we have to be focusing on that 5 as well. And so one way as teachers we can address this is with true false questions. We want kids to be flexible with their thinking about equality. And so we don't actually have to have just an answer. 3 plus 4 equals 4 plus 3. That's true. That's a true statement, even though it's not set up in the traditional way. Again, it's okay to have the answer on the left. It doesn't have to be set up in the traditional way. This is a true statement. 8 equals 8. That's also true. There doesn't have to be an operation involved. Just because this one's set up correctly, it's not true. It's 3 plus 4 is not equal to 6, but even though it looks like a correct, proper equation. And then we can even be, we can do things like this. This would be 1 equal to 8. And of course, that's not true. So this would be something as teachers, we could do lots of true false, having kids give thumbs up, thumbs down, and being really flexible and looking at how equations can be set up. All right, this actually comes from one of my kids' papers that was sent home from school one year. And then this was also another example of how we have to be really careful about the makes. There's a danger of carry-on equations where teachers tend to write strings of numbers together, and it makes it appear that two things are equal that really are not. So for example, if we were trying to add 73 plus 28, this is a great strategy. I love this strategy. We think about it as 73 plus 20, which is 93. And then we would add 8 to it. So the thinking behind this is correct. The problem is that the way that this is written down is saying that 73 plus 20 is equal to 101. And then similarly here, when we did 73 minus 28, again, the strategy, the thinking's a good. 73 minus 20 is 53. And then we would subtract 8 and have the answer would be 45. But 73 minus 20 is not equal to 45. And so as teachers, we need to make sure we're modeling proper use of the equal sign. If you remember, that was actually one of the very specific standards that was named, that we must be very, very precise. And so as a teacher, we should actually write these as separate lines. We would write 93 here, and then on the next line, we would write 93 plus 8 equals 101. All right, here's another one. Elementary school teachers are always saying you can't take a bigger number from a smaller number. And then kids get to middle school and their middle school math teacher says, okay, we're gonna learn about negative numbers now. And the kids are like, what? We were told we can't do 4 minus 7. Well, in fact, you can. We can do 4 minus 7. It would be -3. And if we could do it like that. So here's how it would work. We could do 4 minus 7 is -3. 20 minus 50, notice I'm really focusing on the place values here, is -30. 100 minus 0 hundreds is 100. And then I can think about this as 100 minus 30 minus 3. So this is just another way of thinking about subtraction. And in many ways, I think many adults actually do this in their head. They might not write it down that way, but it's just another way of thinking through it. And then here's the traditional algorithm where sometimes teachers say you can't do 4 minus 7, so we have to go next and regroup or borrow or regroup. But really all we're doing is we're using 10 from here, 10 from the 2 10s, bringing one of those 10s over here, making it 14, and then 14 minus 7. And so when we're talking with young children about this, we really want to just say things like, we could do 4 minus 7, but that will be a negative number. And for now, we're going to avoid that. And young kids, they know negatives. Some teachers act as if we can't talk about this with kids, but they're aware of temperature and debt and spending more money than we have. So kids are aware that these numbers exist. We just don't have to get into all the details when they're very young. All right. Sometimes when we're talking about fractions, we say that the denominator tells us how many pieces there are altogether. And that works when we're talking about a fraction that's less than 1. However, when we're talking about something like 6/4, the 6 is telling us how many pieces we have. The 4 is not telling us how many pieces there are altogether, because the 4 is actually telling us how many pieces are in one whole. And so sometimes kids who think that it's how many pieces there are altogether will look at this. If we've defined one circle to be one whole, this is showing 6/4. However, kids might look at this and think that this is showing 6/8. So there's two big things here. We have to make sure we're talking about what the whole is, and that the denominator is telling us how many pieces there are in one whole, not all together. And here's the Common Core standard for 3rd grade. This is actually how it's defined for 3rd grade. This is what 3rd graders need to know. The denominator tells us, names the kind of fractional part that's under consideration. And then the numerator is telling us how many of those parts we're looking at. All right, fraction pieces must all be the same size. Are these fourths? What do you think? Give me a thumbs up if you think those are fourths, thumbs down if you think they're not fourths. Okay, I've tricked you. These actually are fourths, and we can, let me get my pen out. Options, pen. Okay, what if I draw a line like that? Ooh, that was ugly. Like that. All right. So now would you agree that these are each 8ths if I had drawn more accurately? Okay. And so then we have 2 8ths here, right? 2 8ths, 2 8ths, and 2 8ths. And so, but this is because in school, almost every fraction drawing you've ever seen has probably shown all of the pieces looking the same. And so we've internalized that, but really they don't. They just have to be the same size. They must be the same area, but they don't have to be the same shape. They don't have to look the same. Oh, that was better done. Okay. And this is again from 3rd grade, actually, that students in 3rd grade need to recognize that equal shares of identical wholes need not have the same shape. This one comes again from my own children. When my daughter was in kindergarten, she brought home this little poem. It was a worksheet. And this poem, rectangles have 4 sides, but they're not the same. 2 are short, 2 are long. A rectangle is its name. And there were pictures of squares and rectangles all over the paper, and she was supposed to cross out all of the, I guess she was supposed to cross out all of the rectangles and circle the squares, as if squares and rectangles were these 2 totally separate ideas. But in fact, squares are rectangles. Squares are just special rectangles. And so we really need children to understand how something can fit in multiple categories. And so one example that I think is useful for this is thinking about plants. So we could have a Venn diagram where we have I've hidden it for right now, but under here we have foods. And over here in this circle, we have plants. And of course, yeah, roses, pine trees, daisies, those are all examples of plants. However, we're leaving out all of those edible foods, all the edible plants that are also plants. So something can fit in multiple categories. This is similar to how quadrilaterals are defined. Rhombuses are quadrilaterals that have 4 equal sides. Rectangles are quadrilaterals that have 4 right angles. Squares fit into both of those categories. Squares are both rhombuses and rectangles. And so this would be similar to how a carrot is a food, yes, and it's also a plant. However, it's both of them. And so something where we're telling kids to cross out all of the rectangles, but not wanting them to cross out the squares is misleading. It's like saying cross out all the plants, but except for the ones that are edible, or, you know. So we have to be really careful about that. And this is actually my favorite one because this is something that has changed over the years. When I was a child, when I was in school, and actually up until about 10 years ago, I always believed that a trapezoid had exactly 1 pair of parallel sides. Did you guys learn it that way? Do you remember your definition? Yeah, I mean, that's how every US textbook has always talked about trapezoids. And then I was reading an article and it just mentioned something about it, and I did some research about this. The rest of the world has always defined trapezoids to have at least 1 pair of parallel sides. And it actually works out very nicely if we kind of broaden our definition of trapezoids and we say that it's at least 1 pair of parallel sides. And so the Venn diagram for that works out much more beautifully. In the past, when we were children, the trapezoid area was over here separate from parallelograms, but now this allows us to think about parallelograms as special trapezoids. And this works out really nicely with some geometric software for programming. It's really easy to program that 2 sides must be parallel. It's very hard to say that the other 2 sides can never be parallel, that they could be anything except for parallel. And then also when we're thinking about definitions, if we're finding the area of a trapezoid, we're finding that we have a formula for the area of a trapezoid. Well, that formula would actually work for parallelograms, rhombuses, squares, and rectangles. And so there's a lot less to remember. We can use the exact same ideas there. All right, so that was a lot to go over, and just a little taste of some of the things that I research and I do. This, as I said, this comes from an article that I published in Teaching Children Mathematics in 2014. There's another fantastic article pretty similar to it about 13 rules that expire. And I just wanted to share that with you. My email address is right there. It's just my last name, graybeal@hood.edu. And I welcome any questions you ever have about any of this. I also have, I'll pause there for a second unless anybody has any questions about that part. All right.
No questions. I learned a lot.
Good.
I just had no idea about a lot of these things that you mentioned. It was very interesting.
Good. Let me give you a little bit of an overview of the education programs then. I also have a slideshow for that, so I'll just do a quick overview. And again, as we're talking, pause and let me know if you have any questions. All right, is the presentation showing okay? So as I mentioned, Hood offers early childhood education, which is pre-K through grade 3. And then I talked about the elementary special education program. And then we have secondary education in math, history, English, biology, chemistry, French, Spanish, and then art education as well. So we offer a variety of areas. For the early childhood education and the elementary special education, that is the major. In secondary education or art education, you would major in whatever content area you would be teaching, and then you do the education coursework as the certification track for that. In years 1 and 2, we have you focus on your major if you're in the secondary education program, and trying to get as much of the core, the hood core, done as possible. And so are you familiar with the core and those kinds of requirements? Like there's quantitative literacy, English, languages, philosophy, all kinds to make sure you're well-rounded and a true liberal arts education there. And then in year 3, you really begin to focus a lot on education. We break it up into different phases. In order to enter phase 1, you must have at least a 2.75 GPA and pass the Maryland state requirements for basic skills. And so there are some SAT scores, ACT scores, Praxis core scores that are defined to be minimums, or relatively new is a 3.0 GPA. So you have to have at least a 2.75 and then pass those tests to enter phase 1. Or if you have a 3.0 GPA, you're exempt from those tests. Year 4.
I had asked this question earlier based on the SAT score he has right now, correct?
Yes. Mm-hmm. Yeah. Yeah, so you don't need to retake the SAT. It would be based on your highest score that you ever have. So if you wanted to retake it, you could, or you could use the SAT score that you currently have. And then year 4, and all along here, you're taking some education courses. In years 1 and 2, the observations in Frederick County Public School, it's mostly observation in Frederick County Public School. And then in year 3, you begin working with small groups. And then in year 4, you have 100 days of internship. Those are 100 days of full days internship, and that's a Maryland state requirement. All of our field work right now is with Frederick County Public Schools. So we call it a professional development school placement. We have a very close relationship with Frederick County. We have really great mentors. Many of them are actually Hood graduates. You have college supervisors who would be assigned to you and to go out and observe you teaching and interacting with children. The fact that it's a professional development school also means that there would be multiple Hood interns there with you. So there can be professional development that's focused on new teachers and teacher interns. There are many great scholarships available. And so I know sometimes people think that they can't afford Hood, but I strongly encourage you to apply for financial aid and see what's offered to you. Michael, especially if you're interested in becoming a math teacher, we have a fantastic National Science Foundation grant for math and science teachers, which basically pays for the last 2 years of tuition. So if you're not familiar with that, I can get you some more information about that. Are you familiar with that yet?
No, I would love some more information on that.
I will, not sure, I think I have your email address, but if you could put that into chat, I will send that to you.
All right, got it.
We also have a lab school on campus, which is for 2, 3, and 4-year-olds. And so that's a really special thing. It has, it's a preschool for children, but it also is a way for our future teachers to observe young children. And so we have observation booths with the mirrors where teachers, future teachers can be behind the mirror and observing. And then we also do have our interns interacting with the children at times. We have our juniors and seniors become substitute teachers for Frederick County Public Schools. And so this allows you to earn a little bit of extra money, and it also ensures that you're in their systems. And so this year it worked out really, really well. All of our interns were eligible for the vaccination of teachers as well, because they were out interacting with children. So our education students were bumped up in the vaccination line. For some of our seniors who are our highest achievers, we have an honors thesis program, and that is a departmental honors award, and it leads to a special notation on the program at commencement, and just a nice honor to be recognized for your hard work. We have a Teachers of Promise program. It's actually a statewide program where we select some, again, some of our best future teachers to go to this usually face-to-face luncheon. This year it's going to be online, but it's a very nice luncheon in Baltimore to meet some of the greatest teachers in Maryland. And then you're paired up with a mentor teacher in Maryland, just somewhere in Maryland. And that mentor continues to mentor you through your first few years of teaching to ensure that you have a successful transition to your own classroom. And then two of the clubs that we have specific to education are the Student Education Association. They do many activities throughout the year. One thing that they always do, and they are doing this year, even though we're online, they ask recent graduates to come back and talk about the first few years of teaching and give advice to current education students. And then Kappa Delta Pi is our honors association for future teachers. And here are some pictures. This is a few of our students a few years ago at Martin's West in Baltimore at the Teacher of the Year Awards. We took our students there, some of our best students again, to go see how teachers are recognized in the state. I think these are two of our students at a conference, presenting at a conference. And this is a partnership that we have with a local elementary school where we bring, again, these are all things that we would normally do, but they're not happening this year. We usually have our college students pen pal with the children at a local school throughout the year, and they read the same book and they discuss it. And then in the spring, we have the children come to campus and have a whole day on campus touring. We do mini classes, pretend like they're in college, take them to the cafeteria for lunch, which is a huge hit. They get all you can eat ice cream. It's just a nice day for the kids to visit college and aspire. It helps them think about what they want to do in the future and hopefully want to go to college as well. So as I said, I'm the chair of the education department, so I can answer any questions you have about all of the programs, but we do have coordinators of each of the different programs. So for early childhood education, we have Dr. Torres Crespo. Elementary special education is Dr. Strickland, and secondary education is Dr. Grove. And so if you wanted to contact any of them also, I'm sure that they'd be happy to talk with you. Oh, and here are just a couple more pictures. This is at the lab school. And this is again, usually we have a education department field day in the fall where we play kickball and hula hoop and have fun outside together. Right, so that's everything I have prepared. Is there anything else that you would like to talk about or any questions you have?
Graybeal, or Dr. Graybeal, sorry.
Sure.
What states does his certification transfer to in secondary ed?
So Maryland is part of the Interstate Reciprocity Consortium, which allows certificates to transfer. Well, it's not a direct transfer. No state will promise that our certificate will be a direct transfer and there'll be nothing else that you would ever be required to do. But it does allow you to transfer to, I know it's 50 different areas, but that includes DC, Puerto Rico. So there are a few states that are not included. I do know that Pennsylvania is included. But for all of these, what every state is going to say is, we'll take your certificate and then we'll analyze it and say if there's anything that's missing. And you would be able to teach for 2 years. And then in the next, before we can renew your certificate again, you have to take this course. So for example, I don't know if it's still the case, but Pennsylvania used to require Pennsylvania history, and so they would say, okay, you come teach in Pennsylvania, you can teach for 2 years, but in those 2 years, make sure you take a course on Pennsylvania history or something like that. I was certified in Pennsylvania and I moved to Maryland. This was 20 years ago, but at that point, Maryland happily took me and they said, okay, in your first 3 years, you need to take a course on special education because Pennsylvania had not required this course. So there's very good reciprocity across states. It's just, it's not a perfect, it's not going to be like, you're good forever. They're going to look at your transcript and tell you what you need to do. I will also say that there's such a demand for teachers right now that all of our graduates are, that we already have, our seniors have been receiving offers since January. They're already being snatched up by all the local school systems, anybody, occasionally we do have people who complete our teacher education program and they say, you know what, this is not for me. I thought I wanted to become a teacher, but I'm realizing it's not for me, and they don't become teachers. But everybody who completes and says, yep, I want to be a teacher, they are all hired right away. And we do have them move back home sometimes to New Jersey, New York, Virginia, and then sometimes internationally. We've also had a few graduates decide to go teach in Korea, Hungary, Germany, you know, so sometimes people decide to go teach abroad.
There enough time for a student to have a minor?
Yes, it'll be tough though. It would be something that you would want to make sure you talk with your advisor at the very beginning when you're planning out your courses from day one and try to figure out how you're going to make it fit in there. What are you thinking about it minoring in, Michael?
Not sure, to be honest. I think that was just a curiosity question from my mom.
Yeah. Is there anything else I can answer or talk about?
Not that I can think of, no.
Yeah,
All right.
I don't have any questions either.
Good. Well, I hope Connie feels better. Please.
Yeah, it's just the day after we get all these different side effects and things. But
Yeah.
I'm sure she'll get better. So
Yeah, and tell her to, if she wants to set up a time to Zoom or talk, I'd be happy to do that too.
oh, okay, all right. Thanks.
Okay.
Thanks very much.
Yeah. Good. All right. Well, if there's nothing else I can do for you, feel free to sign off. But I'm also happy to hang around if anybody wants to talk about anything.
Okay,
Right.
Dr. Graybeal, thank you. I appreciate your time.
You're welcome. It was nice to meet you.
Yeah,
Nice to
thanks
meet
very
you.
much.
All right, I'll see you.
All right. Bye.
Bye.